Is order of operations as simple as it really seems, or are there some tricks? In this video, I want to talk about a few of the subtleties that aren't necessarily obvious if you learn the acronym PEMDAS to represent the order of operations. So let's review quickly. PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. And this order tells us how to do operations within a given arithmetic problem. So let's look at a problem like 12 divided by 4 times 3. If you're following along with PEMDAS, perhaps you're just thinking, okay, parentheses, I don't have any, exponents, I don't have any. There's some multiplication, so let's do 4 times 3 first, and 4 times 3 is 12, and then following along, next would be division, so 12 divided by 12 is 1. This seems natural, but there is a trick to PEMDAS, and you might actually know this. In addition to doing those operations, you also need to remember one of the rules that's not mentioned in PEMDAS, which is you must work from left to right within a given step. The other thing you need to know is that multiplication and division are actually considered to be the same step, and similarly addition and subtraction are the same step. So the correct way to work this problem is not to do the multiplication first. It's actually to do parentheses, then exponents, and then at the same time do all multiplications and divisions in whatever order you see them from left to right. So here we would do the division first. 12 divided by 4 is 3, and then 3 times 3 is 9. So this actually equals 9, not 1. So if you have a problem with a mix of multiplication and division, maybe it's division, multiplication, multiplication, division, division, you would not skip around and do the multiplications first. You would just work left to right doing all of these different operations. So first, second, third, fourth, and fifth. Now if you had some addition and subtraction mixed in there, you would still skip over those. So if this were like division, addition, multiplication, okay, then you would still do division, multiplication, division, division, and then go back for addition in the next step. What about the problem 6 minus 2 divided by 5 minus 3? What would you do first here? Let me give you a couple seconds to think about this. So I think what you would probably do would be to subtract 6 minus 2 and subtract 5 minus 3, and then divide 4 divided by 2 to get the answer 2. Now that is correct, but let's look at the order you did this. We did a subtraction, and then a subtraction, and then a division. So thinking to the order of operations, we're actually supposed to do multiplication and division before addition and subtraction. So why in this problem do we skip and do the subtraction first and then back up and do the division? It seems like we're doing the order of operations actually out of order. So we need to explain this, and this also is not clear in PEMDAS, but sometimes in these problems we have parentheses that are implied. So here there's actually an implied parentheses around the numerator and an implied parentheses around the denominator. So it's not actually that we were doing 2 subtractions first. It's actually that we were doing 2 parentheses first and then a division. So that does follow order of operations. You would do the parentheses first followed by division. All right, so in general, a good rule to remember is to be aware of implied parentheses like this, and to make sure you do those things first. And you may even want to just write in the parentheses anytime you feel like those are necessary. So for fractions, if you have anything like multiple things in the numerator or denominator, multiple terms, or even just an operation in numerator and denominator, it's probably a good idea to put parentheses. So if you had something like 3 times 4 divided by 5 times 2, just be aware that you need to do 3 times 4 and 5 times 2 first, before you do that division, okay, but using order of operations. What about something like -3 squared? Right now I'm writing it like this. I want to be very careful about this one. Try this on your own first. So if you have a calculator, type this in exactly as you see this written and see what answer you get. So the interesting thing here is that depending on the calculator you're using, you may actually get different answers. So in particular, many of the cell phone calculators, if you type this in as -3, or maybe you have to hit 3 first and then the little negative symbol, and then you hit your exponent key, so maybe it looks like x to the y or y to the x, right? And then a 2 for squared. If you input that, that's actually going to give you a 9, whereas if you're using maybe a scientific calculator like a TI-30 or some other, maybe a Casio, something like that, if you enter the exact same thing, you will actually get a different answer. You'll get -9. Right? So which of these is correct? Well, we need to talk about the notation here. So it's not actually that this expression has two different values. It's just that one calculator is interpreting it differently than another calculator. All right, so when we see this notation, what's actually meant is we have a number at the base of the exponent, which is actually a 3, and we are supposed to square the 3, okay, meaning do 3 times 3, and then go back and make this negative, right, or multiply by -1. So the correct answer here, what's actually meant by this notation, is -9. All right, so this is correct. If your calculator does that, then you're good to go. However, if you have maybe a cell phone calculator or something else and you get a +9 as your answer, what the cell phone's actually doing, it's not really doing order of operations here, but it's taking this -3, and then when you hit the exponent keys, it's saying, okay, take -3 and multiply it by itself. So it's just doing something different. Now here's maybe another way to explain this. Oops. Right, this notation means -1 times 3 squared, right, or -1 times 3 times 3. And you can see that that's -9. The cell phone calculator, when you're typing it in, you're actually entering a -3 in parentheses, and the cell phone calculator, or whatever one is giving you a +9, is interpreting that to mean take that -3, the whole thing, and multiply it by itself. So -3 times -3, and of course that's +9. Right? So it's still true that a negative times a negative is a positive. It's just that this original notation doesn't actually mean a negative times a negative. It means a negative times a positive times a positive, which is negative. All right, and then maybe one other way to think about this first expression that could be helpful. You can think of this as 0 minus 3 squared, right? And then if you were to follow order of operations here, you would do an exponent before you do the subtraction. So this would mean 0 minus, and then you would do 3 squared next, which is 9, and then 0 minus 9 is -9. All right, so to review, if you see something like this notation means -25, and this notation means +25. Here's another tricky one. What is 10 to the exponent 2 times 3? All right, so here the first thing you would do is multiply 2 times 3 to get 6. And then the next thing you would do is do 10 to the sixth power, which is 1 with 6 zeros, or 1 million. Okay, so that was the second thing we did, was the exponent. So again, why are we doing this? It looks like out of order. from PEMDAS. We're doing multiplication before an exponent, which looks a little bit weird. But the same reason applies as the first thing we talked about. There is an implied parentheses around this little exponent. And we can tell that that's the case just by looking at the font size. So if the numbers are very small, then they're all a part of the exponent, and there's like an implied grouping there with everything that's up in the exponent. And that would be true too even if we saw like a plus sign up there instead of a multiplication. So we would still do that addition first, and then go on and do the exponent. All right, so you'll encounter things like this first example when we discuss maybe financial math. You might have multiple numbers being multiplied together in the exponent. So to summarize, 3 different cautions with order of operations. Look for implied parentheses. Make sure you're working left to right so that you would do all multiplications and divisions from left to right, and then all additions and subtractions from left to right. And then finally, a third caution, watch out with exponents and negatives. Make sure you know the difference between the exponent of a positive number that's then made negative versus the exponent of a negative number. 2 different things.